And hello again YouTube to this video discussion. We're going to continue our CHT multi-region from example case, and we're going to start something simple. Of course, we were doing a hot sphere in oil, and we have just successfully used snappy hex mesh to generate this mesh of this small little sphere in this large volume of oil. Of course, it is not ideal because the sphere is way too small in comparison to this very big block of oil. So perhaps in a future version of this hot sphere in oil case, we can actually decrease the size of the oil to fit what we want. But for now, maybe what we want to do is just quickly run through chtMultiRegionFoam and its features. So we want to go on to the next step. So let's go to or run serial pre, right? To figure out what the next step is. So I'm going to VI the thing. So we have already run through the block mesh and surface feature extract and snappy hex mesh. Of course, we can make the case a little better, especially with regards to the relative size and of course the shape of the little sphere in the center, which doesn't really look like a sphere now. We can of course add layers as well. But that's in like future versions of this what do you call that? Hot sphere in oil. We can do a hot sphere in oil version 2 to kind of do some improvements on what the case should be like. Okay, so after split mesh regions, we saw that we have split the region into two. Split the mesh into two regions. We can look at this next part, which is removing all of the non-relevant files for the solid, and this one's pretty straightforward. Okay, we saw what it did in the last few videos, and of course when we use this bracket notation, we should always make sure that the bin and bash pound sign key is on top there, so that it will refer to the correct, get the correct libraries or something like that. So so that when you run this remove operation, it will remove all these fields. So what are all these fields? These are usually properties related to fluid. For example, the U is the velocity. K and epsilon are of course the turbulent properties. K epsilon model. If you're not familiar, you can go and look in my other videos. Alpha T. This is actually the thermal eddy diffusivity, and nu T is momentum eddy diffusivity. If you're not sure, you can what these are, you can always look here. This is a thermal eddy diffusivity. Okay, so let me take a look. I remember I put it in one of these tabs. Yes, alpha T is a thermal Bohr function for thermal diffusivity. And what is thermal diffusivity? If you look at Adrian Bejan's convection heat transfer, this is basically, we do time averaging of the convection and conduction equation, and we equate one of these, the time varying terms to the eddy diffusivity or eddy heat flux, as you can see here, and we substitute that back in here so that we can get an expression like so. Where is it? Yeah, we can get an expression like this. We get alpha plus the eddy thermal diffusivity into partial of the average temperature with respect to y. You get something like this here, and that's what it's about. And the same thing for the momentum equations can be done, and yeah, this is something with regards to fluid properties. PRGH, what is that? This is actually it takes into account hydrostatic pressure effects, and what it says is that for example, for buoyant and multi-phase cases, we have this P prime, which you see here in the middle. It is actually the pressure but you subtract off the hydrostatic contributions. So this is what PRGH is actually about. Okay, so if you're not sure, I mean, I'll put these links in the description below. So yeah, don't need to worry too much about what these are. Okay, so these are all fields that are related to a fluid. And the next thing we want to write is our changeDictionary, which is actually our boundary conditions. So let's take a look at what the 0 file actually has to offer, because that's where we usually have our boundary conditions. So we have our files here, all these files that were originally written in the 0 and the 0 original file. But because we split the mesh, we ran a split mesh regions, we have two regions here. Now there's the oil and the sphere. So for example, let's take a look at VIT. So what you'll find here is this dimensions and internal field uniform at 300 Kelvin. And of course this boundary field, which has this funny include etc. case dict constraint types. Well, what is this actually? If you look at this forum file, basically it's referring to another library. So, well, what am I talking about? If you take a C++ before, it's grabbing a lot of definitions and whatever from another file. So if I go to this, go to foam, cd foam etc. That's where you'll find the files. Let's go to case dicts and vi set constraint types. This is the file it's actually referring to. Set constraint types. So okay, let's look at all this. These are all the definitions, so that if you actually write your boundaries as any one of these files, automatically the type of the boundary condition is automatically specified using this this library. But because the thing is that you don't want to keep writing all of these into the boundary field, you don't want to write these in our boundary field, you simply truncate it by writing all of these in another file, and I say, okay, please refer to this file to get all these definitions that you see here. Though for our case, it's not really necessary. Not necessary for our case, but this is just to clear up confusion as to what this actually is. And then you'll have this thing here, it says dot and star calculated type calculated value internal field. So what is this saying? It's saying that for every patch, patch that you see, that it's there can be any name. That's what the dot and star is there for. When you run the split mesh regions, whatever the patch is, you will type in this. You will put in these values into the file, into the folder there. So we see for this case that we copied from the snappy multi-region heater or snappy multi-region file, we see that pretty much all the boundary fields are written in a very similar fashion. Okay, don't worry about it first. And then if you're asking how do we differentiate, write our boundary conditions individually for the oil and the sphere, that's what changeDictionary is there for, and this is what the video is here to show you to do. So again, alpha t is also the same pattern, similar pattern, so I'm not going to do that. Continue on. But what I want you to pay attention to for now is the oil folder, which has all of these written in it. And to see how it actually plays out and how the boundaries are actually written, we can take a look at the temperature folder, the temperature file, and in there you will see again all the type has become calculated and the value is uniform at 300. Okay, so the min, the max y, the min x, max x, min y, etc., these are from the block mesh. block mesh boundary field or the patches or whatever. It is written in the block mesh stage when we make that gigantic block of oil. What the OpenFoam does is that, hey, for any boundary field, any boundary there, we will have all of these values put in. Okay, all of these values will be put in. This moment we want our snappy hex mesh, and after that the slit mesh regions. And of course there is this extra little boundary here that's called oil to sphere, because between the oil and sphere there will be another boundary that we need to take care of. Now the question is, are we going to write all our boundaries here? Answer is no. What we are instead going to do is take a look at our changeDictionary file. Okay, so let's go to changeDictionary. So cd, and I'll go to GitHub, OpenFoam workspace, and of course I actually already uploaded the past video stuff up to GitHub, so all the changes will have been recorded there. OpenFoam Heat Transfer YouTube, chtMultiRegionFoam, and hot sphere in oil. Yeah, what are we supposed to do here? The next thing to do is to take a look at system, and we want to take a look at specifically the oil, and we want to look at changeDictionary.dict. Okay, apparently there's no changeDictionary here, so there must be something. We need to copy it over. So if you take a look at FV schemes and FV solution, which we can discuss in the next few videos, there's basically nothing inside there. Via FV solution, there's basically nothing in there. So we'll need to start writing something in later. But for now, we just worry about our what do you call that? We want to start worrying about our changeDictionary. So let's copy the changeDictionary into each of these cases. So for this oil is a fluid, so I'll want to copy the changeDictionary from, let's say, bottom air. So let's go to bottom air, and let's go and look at the changeDictionary dictionary. All right, so this is what we have here, and this is where you actually have the boundaries. Okay, you see the boundaries. All right, so we'll copy this over, and then we want to go through it one by one. So cp ar changeDictionary dictionary, and we want to go to backtrack and put into the oil. So that means yeah, we go one folder up and then we go into the oil. So you can see we have the changeDictionary dictionary here, and let's go and change it and edit it. So basically what we want is for all the boundaries to become a wall type. So not only do we want min x and max x to be a wall, we want everything to be a wall. So okay, let's just type it in here. So this is how we edit the boundary conditions. All right, so min y, and then I'll open and close the bracket. You know what, this is the more efficient way. Escape and delete these two files. Oops, undo. Okay, I'll paste it twice, and then let's just have min y and z, min y, max y, min z, and max z. Remember, this is what we wanted our files to contain. So what next? Next is we want to take a look at the u velocity profile. So let's go to u. Okay, via u, and here we have everything that we want. So what do we want our internal field to be? So changeDictionary, remember, it takes everything from here and it plots it into here. Okay, so all right, I think this was a mistake here. There should not be a min y there. Okay, what I mean is this. In the u in this u changeDictionary entry, there should not be a min y over here. I'll just want to double check that by looking back at the u folder inside bottom air, changeDictionary dictionary, changeDictionary dict. So we take a look at the u, and indeed there's nothing else here. So okay, yeah, I just want to make sure it's copied over right, because it's copied over correctly, because can get pretty easily messed up when we copy and paste a lot of things. So okay, again, this is the original file. This is the original file. So we want to go system and excuse me there, so sorry. We want to go to our oil and we want to see the changeDictionary dictionary. Okay, so first thing first, we want everything here to be a wall, because that's what the boundary is supposed to be. Okay, so next thing, we want the initial condition to be like a still kind of a steady kind of a flow. Okay, meaning to say I want my oil to be completely still at the beginning. So the internal field should be 0, 0, 0 everywhere. Okay, internal field should be 0, 0, 0 everywhere. Boundary field, I want everything at the wall to be 0 and it's a fixed value. So it's going to replace all of this with fixed value and uniform 0, 0, 0. That's what I want. Okay, so I'm going to write it in, I'm going to save it. And processor boundary, this I'm just going to leave it because this is for parallel. Okay, now next, we'll want to, of course, take a look at this oil to sphere. So this thing has to change a little bit. So what how changeDictionary, when you run it, if it is just having this code, is going to say, hey, boundary field, I want everything, because I put dot dot star here, everything with any kind of a name, I want to put it at a fixed value and a uniform 0, 0, 0. So I'm going to take this and replace it with this. I'm going to take this calculated uniform, type calculator and value uniform 0, 0, 1, 0, 0. I'm going to replace it with this, etc., etc., all the way down. Then it's going to take the processor boundary, and then it's going to put a type processor in, and which is fine. But next thing you want to do, of course, is to edit this oil to sphere. And what should this oil to sphere thing be? So okay, let's just put that in, or we just give it some thought. Between the oil and sphere, there should be 0 velocity, because this oil and this sphere is supposed to be at rest within the oil. So I do not want any kind of movement within there. I do not want any movement. There should be a no slip condition, since this is a solid and a fluid coming in contact. So at that point, there should be a no slip condition. However, it is kind of redundant if I just put replace this with fixed and uniform 0, 0, 0, since all of this, every single boundary between the velocity and the fluid and the solid is going to be a no slip condition. So it's kind of redundant. So I'm going to just delete this. Okay. Save first. And I'm gonna stop here for now because it's at 20 minutes. So we'll just discuss the change dictionary for the oil for the velocity boundary conditions. Next video we want to go on to temperature, and this will be slightly more interesting than the velocity. So thanks for watching. I'll see you guys next time. Bye bye.